We've seen this graph in the previous video. It represents the pressure and density variations of a medium as the sound wave travels through it. We can see that the sound wave is a continuous cycle of high-pressure regions called compressions and low-pressure regions called rarefactions. When does the sound wave complete one complete cycle? When the density in the medium moves from the maximum value, that is this one, to the minimum value here and back to the maximum, we say that the sound wave has completed one oscillation. This is one oscillation of a sound wave. Maximum to maximum. And from this point to this point will be another oscillation and so on. There is another way to look at this cycle. When a sound wave moves from this point to this point, we say that it has completed one oscillation. Both representations of oscillations consist of one compression and one rarefaction. In our videos, we will refer to the first one. Now, with the relation to this figure, we will try to understand the frequency, wavelength, and the time period of a sound wave. Now, do you remember what frequency is? Yes, the number of oscillations per unit time is what we call the frequency of a sound wave. If we can count the number of oscillations passing through a fixed point in 1 second, that will be the frequency. The frequency is represented by this Greek letter nu, and it is measured in hertz. So if we look at this point, how many cycles crossed it in 1 second? Yes, 2. So we say that the frequency of the sound wave is 2 hertz. Let us see what the wavelength of a sound wave is. The distance between the peak value of 2 consecutive compressions or 2 consecutive rarefactions is called the wavelength. So this distance is the wavelength of this sound wave. Or it could also be this distance. Both distances are the same. So we will refer to this one in our videos. We have seen previously that this is nothing but one oscillation completed by the wave. So we can say that the wavelength is the length of one oscillation. It is denoted by this Greek letter called the lambda. What do you think will be the SI unit of wavelength? You should be able to guess this by now. Since it is distance, it is in meters. The word wavelength also has the word length in it. So it's nothing but the distance. Finally, we will talk of time period of a sound wave. The time taken by 2 consecutive compressions or rarefactions to cross any fixed point is called as the time period of a sound wave. So if a wave takes 2 seconds to pass this point, we say that the time period is 2 seconds. Is there any other interesting way to define it? We can also define it as the time in which a wave moves the distance equal to its wavelength. If you remember, the wavelength is nothing but the length of one oscillation. So the time period can also be defined as the time in which a sound wave completes one oscillation. It is denoted by capital T and its SI unit is seconds. Let's do a quick recap here. We understood the concept of frequency, wavelength, and time period of a sound wave. The frequency is nothing but the number of oscillations per unit time. If we can count the number of oscillations passing through a fixed point in 1 second, that will be the frequency. And wavelength? The distance between the peak value of 2 consecutive compressions or 2 consecutive rarefactions is called the wavelength. And what about the time period of a sound wave? It is the time in which a wave moves the distance equal to its wavelength. Did you know that there is some relation between the time period and the frequency of a sound wave? What is that relation? Keep watching our videos to find that out.